Europe's power grid is basically having a nervous breakdown every time there's a heat wave. And it's because the infrastructure was designed for a completely different climate than what we're living in now.
Okay, so when you say designed for a different climate, we're talking about what equipment from decades ago?
Right, exactly. Engineers built transmission lines, transformers, power plants, all of it, based on historical temperature data that basically said summer heat was rare. But what used to be a once-in-50-year scenario is now happening every few summers. And the hardware just was not rated for these temperatures.
So the cables and equipment physically can't handle sustained heat. How does that actually break?
Well, transmission lines literally sag when it gets hot, because the metal expands. That reduces clearance from the ground, which is dangerous because the cables could touch vegetation or something and cause problems. Operators have to cut capacity to keep it safe. And then transformers. Those are the devices converting voltage across the network. They generate their own heat when they work, and their cooling systems just can't keep up when it's already 40 degrees Celsius outside.
So the transformer is basically trying to cool itself, and it just loses the battle.
Exactly. Efficiency drops, and in severe cases, they fail completely. But here's where it gets really interesting and counterintuitive. The supply side gets crushed by the same heat wave that's driving demand through the roof.
Wait, so it's not just that everyone turns on their air conditioner at once?
No, that's only half of it. At the same time, everyone's cranking their AC, multiple power sources are getting knocked offline. France gets about 70% of its electricity from nuclear, right? And nuclear plants need river water for cooling. When rivers get too warm or levels drop too low during a drought, they have to shut down or reduce output to avoid damaging the environment. So you lose a massive chunk of supply exactly when you need it most.
That's kind of brutal. They're forced offline by the same weather event that's killing demand.
Exactly. And it's not just nuclear. Coal and gas plants also need cooling water from rivers and reservoirs. Thermal power? Same problem. But then solar and wind, which people think of as the saviors here, they have their own heat wave issues.
Really? I would have thought solar would be doing great in a heat wave.
So here's the thing. Solar panels actually lose efficiency when they get too hot. Efficiency drops above roughly 25 degrees Celsius. So during a peak heat wave, when those panels should theoretically be pumping out maximum power, they're actually underperforming. And wind? Heat waves are caused by these stagnant high-pressure systems that suppress atmospheric movement, so wind speeds drop, turbines produce less, and that buffer is gone.
So you've got this synchronized collapse where nuclear's down, thermal's throttled, solar's underperforming, wind's stalled, and meanwhile millions of air conditioners are running at full blast.
That's exactly right. The grid was never designed to handle that kind of compound failure. It was built for cold winters, not scorching summers. And now we're seeing this feedback loop where more Europeans are buying air conditioners for the first time, which drives peak demand even higher on the hottest days.
How much are we talking about in terms of AC adoption?
So air conditioning ownership in Europe is way below the United States. Germany's at around 10% of households, compared to like 90% in America, but it's climbing fast. And each percentage point of new AC ownership translates into gigawatts of new peak demand.
And this creates a feedback loop, right? More air conditioning means more emissions, which accelerates warming, which makes people want more air conditioning.
Yeah, and the grid infrastructure was never sized to absorb that loop. The real danger is when entire regions get hit at the same time. France, Spain, Italy, Germany, all baking under the same weather system. Cross-border electricity trading, which normally helps balance things out, doesn't work because everyone's pulling from the same constrained pool simultaneously.
So basically, the grid can't borrow power from a neighbor, because the neighbor is in just as much trouble.
Exactly. And this is becoming more common, not less common. The reality is that Europe's entire electricity system was engineered for a climate that doesn't exist anymore, and that mismatch between the infrastructure and the actual conditions is what's creating these crisis situations every summer now.
It's a pretty sobering situation. So what's the solution here?
That's the million-dollar question. And the article goes much deeper into what happens next and what's actually being done about it. If you want the full picture on this, head over to newslit.com and check out the full article. It's really worth understanding what's at stake here.